one setting in Claude Code, hand it a big job, and the AI does something strange. It stops trying to answer you. Instead, it writes a program, and that program spins up an army of copies of the AI. 50 of them, sometimes a few hundred, all running at once, each on its own slice of the work. The one in charge runs the whole operation from the code it wrote, and never even holds most of what comes back. Anthropic shipped this on May 28th, a feature called Dynamic Workflows, switched on by something that sounds like a cheat code, ultracode. People can't agree whether it's the biggest leap in a year or an expensive way to burn money, but that argument isn't the interesting part. The interesting part is how it pulls this off at all, and the question hiding underneath it: what does an AI do when the job is too big to fit in its head? Now, if you've been around this stuff, you've already got a reaction, and it's a fair one. This is just subagents. We've had that for a year. One AI hands pieces of a job to a few others and stitches the answers back together. Cursor does it, Codex does it, everybody does it. Splitting work isn't new. And that reaction is almost right. But there's one difference between this and the subagents we've had all along, and it's the one that matters. Here's the difference. Normally, the AI in charge runs the whole show from inside its own head. It reads every result, holds the whole plan, decides each step in its own words. And that's the ceiling, because its head only holds so much. Pile in 50 agents worth of output, and it drowns. The new move flips it around. The model writes a little program. Anthropic calls these dynamic workflows, and the program runs the show. The agents report to the code, not to the model. That loop, the part that fans the work out and gathers it back, runs off to the side as plain code, and it never costs the model a single thought. It writes the machine, kicks it off, and steps back. 50 agents don't drown it because it was never holding their output in the first place. Researchers have a name for this shape, a recursive language model, out of a paper from MIT. And the idea is almost too simple. Stop feeding the model your data. Leave it in a variable, off to the side. Tell the model one line. It's over there, 500,000 characters of it, and make it write code to reach in and pull back only the scraps it needs. The data never enters its head. It pokes at the problem from outside, in code, the same way it runs the agents. One trick pointed at two things. Strip it down, and the definition is 3 rules. The model gets a handle to the data, never the data itself. It keeps a workspace that remembers between steps, so it builds the answer up piece by piece. And calling another model is just something its code can do, in a loop, as deep as it likes. That's the whole thing. Python, sandboxes, plumbing. So why go to all this trouble? Because one head holding everything breaks in ways you've probably felt. Give a model a big, messy job in one long session and watch it happen. It gets to item 20 of 50 and declares the whole thing done. You ask it to double-check its own work, and it waves its own work right through. And after enough back and forth, the one rule you actually cared about, don't touch the live database, quietly falls out the bottom. The more it's holding, the worse it holds any of it. The fix isn't a bigger head, it's a smaller one at the top. Think of a company that actually works. The CEO doesn't carry every detail. They get a one-line status, not the cleaning schedule for the 3rd floor bathroom. Every layer keeps its own mess to itself and passes up something clean. That's the cure for a rotting context. The grubby detail stays sealed inside a subcall or a variable, and the top only ever sees the summary. And it reaches further than you'd think. The model can even load its own conversation into the workspace and read its own history on demand. It manages its own memory. And managing what you hold in mind is everybody's problem. And the recursive part is just that same company, one floor down. A huge project lands, too big for one person, so the boss carves it up and hands out the pieces. That's your subagents, one level deep, nothing fancy. But real work is messier than the plan. Someone hits a problem nobody saw coming, and fixing it turns into its own little project. You don't kick that up to the CEO. The manager standing right there spins up their own small crew, handles it, and the work rolls on. That's recursion. Anybody, at any level, hitting something they didn't expect can open a fresh team of their own. a manager who's allowed to hire. Okay, but does any of this actually beat just throwing a smart model at the problem? The MIT researchers ran exactly that test on a benchmark built to be brutal, a log of 800 questions, and the job is to sort every one of them, then list every pair of users who asked about similar things. Thousands of pairs, too many to judge by hand or even type out. Hand it straight to a top model and it scores basically 0. The answer's bigger than it can hold, and the middle of the log's already rotted. Give it a sandbox and helper models with the data still riding along in its context, and it claws to 28. None of the standard setups crack 30. Point a recursive model at the exact same log, and it writes a few lines of code instead. Peek at the format, loop through in batches, hand each batch to a cheap helper to label. Build all the pairs in code in a millisecond, and then just point at the variable. That's the answer, never typed out. 58. Let the helpers recurse a few levels deep. 76. Same models underneath the whole time. The intelligence didn't come from a smarter brain. It moved out of the brain and into the structure. And this isn't one company's gimmick. It's loose in more than one place. Anthropic put it in Claude Code, the loud one, and that's where all the noise is. But a while back, we covered a smaller DeepSeek agent called Code Whale running the same trick out in the open. At the end of that one, I said the idea underneath it deserved its own episode, the one we've been pulling apart this whole time. So here it is. The point is, this move is bigger than any single tool, which raises the obvious question. If it's this good, why is everyone so careful with it? Because all that freedom comes with a bill, and the burn money side of that argument has the receipts. Spin up 60 agents and it can torch a day's budget in 15 minutes. Worse, when the model isn't quite smart enough, the agents hallucinate problems, then solemnly confirm each other's hallucinations and hand you a confident report that's pure fiction. The deeper trouble is that knowing when to split a job up and when to just do it yourself is a skill, and models are bad at it both ways. Some refuse to delegate and grind through everything in one window. Others spawn agents until the whole thing explodes, which is why every serious version slaps a hard cap on the depth. Capping is the cheap fix. The hard one is to teach the model the skill, and one lab went and did exactly that. Moonshot trained a version of their model, Kimi, to run a swarm of its own subagents, and what they ran into is the whole point. Left to learn on its own, the model kept sliding into one lazy shortcut, just do the thing itself one step at a time. They gave it a name, Serial Collapse, and had to add a reward whose only job was to push it to split the work up. And since you can't tell which agent in a failed swarm blew it, they froze the workers, older copies of the model itself, and trained only the orchestrator. Isolate the judgment, teach just that. And it paid off. On a brutal web research test, it went from 60% to 78% and ran up to 4.5 times faster. The skill doesn't come free. You box it in or you teach it. And teaching it is probably where this all heads. Chain of thought was a prompting trick once, until labs trained it in and we got reasoning models. Same arc, one step earlier. Scaffolding today, baked into the model tomorrow. So the honest advice ends up narrow. Even the people who built this say it. Save it for your biggest jobs. The migration, the audit across 1,000 files, the thing that won't fit in one head. Point it at a normal task and you've paid a fortune to do badly what one focused model does cheaply. And it only pays off if you've already broken the problem into pieces. Go figure out the strategy isn't a job you can hand it. That's a wish. The machine is ready. Most of the time, the work isn't. Step back and look at the line all of this sits on. For years, we've handed the model more freedom, more tools, more latitude, fewer rails. And letting it write code that calls more of itself is the far end of that line. And it's already here, running today. Go back to that company one last time. It used to be only the boss could hire. Now, any manager, any level, can build a team of their own and wire it together in code, which is wildly expressive. You can do more than split a job up. You can shape how it gets solved. Run a tournament and let a judge pick the winner. Appoint a skeptic whose only job is to tear the answer apart before you trust it. Brainstorm 100 ideas and keep the 3 that survive. or just loop, spawning agents until nothing new turns up. None of those are tricks the model already knows. They're shapes you hand it, in code. And once you're thinking in shapes like that, the question quietly changes. For a whole class of problems, you stop asking, how do I solve this? And start asking, how would I structure a team to solve it? Who splits the work? Who checks it? Who breaks the tie? You stop being the worker on the floor and start being the one drawing the org chart. That company we kept coming back to was never really a metaphor. The catch from earlier still stands. The machine only pays off if you can see the structure hiding in your problem. But that's the skill now, not solving it, organizing it.